All right, guys. Last video. Woohoo! We've almost made it. All right, today I'm just going to go through some examples on your homework too. So you've got a couple guided things to work with here as you work through them. So I'll go through the examples on here, watch them as you need to, ask questions if you need help. But I'll go through some of the stuff that we learned in the notes on your last class. So, all right, first couple here. Sorry about that. First few, it says to expand each logarithmic expression. So remember in the notes, we talked about expanding and then also condensing logarithmic expressions. These first ones, we want to expand them. So we're starting with one logarithm and we're going to make sure we're only taking a log of one single thing. That's how we know it's fully expanded. Okay, so remember our rules here is if we're multiplying things, we can separate that into addition. If we are dividing things, we can separate those into subtraction. And if there is an exponent, we can always put that out in front and multiply. Okay. All right. So if I'm doing log base 8 of 63x squared, right? At 63x squared, there is multiplication between the 63 and the x squared. So the first thing I'm going to do is I'm going to separate this into log base 8 of 63. And since it's multiplication, I'm going to change that to addition. And then log base 8, same base, of x squared, right? So I took the multiplication, separated it into addition. Then I've also got my exponent on my x squared. So then I can make this log base 8 of 63 plus my exponent comes out in front, 2 times log base 8 of x. So you want to remember that your argument, remember the argument of your logarithm is that part right there. As long as that is just one single thing, then you have expanded as much as you possibly can. So that is our answer there. Okay. All right, we'll do one more of these. So I've got another one here, log base 4 of 5/3. This one I've got division, which means I can separate that into subtraction, right? So this would become log base 4 of 5, and we always want to do this in order with subtraction, so it's always top minus the bottom, minus log base 4 of 3. And then I only have a 5 and 3, so there's nothing else I can do there. That's as expanded as I can get with those, or with that one. Okay, so try the same thing on the next 4. A couple are just remember, try to do, if you've got some like on number 2 here, where you've got some multiplication and division, I would, on this one going kind of expanding, I would probably take out the division part first and then work on the multiplication. That will be a helpful hint there. And also remember on number 4, that radical x, remember that's the same as x to the 1/2 power. There's kind of a little hint on those two. If you get stuck, let me know, but those are kind of the two harder ones. Okay, we used expanding logarithms to evaluate and estimate or approximate the value of some logarithmic expressions. So in this one, we are given that log 5 is that, and log 15 is this. By the way, if there's not a base shown on your logarithm, that is always implied that it's log base 10. But it doesn't really matter to us. We're just going to use those two values that they gave us to find the log of another value. Okay, so the one I want to find is log base 3, or I'm sorry, log of 3. So I need to come up with some way to get a 3 out of my 5 and my 15. Well, if I do 15 divided by 5, that's the same as 3. So I'm going to rewrite this as log of 15 divided by 5, because 15 divided by 5 is the same as 3. And then I can use my expansion property here, because that's division, to make it subtraction. So that would make log of 15 minus log of 5. And then I know those two values from what I was given in my directions. So I'm going to make log 15, we said is approximately 1.176, minus log of 5 is approximately 0.699. And then if I do that subtraction, I get 0.477. So that is the approximate value of log 3. Actually, I'll write that out here so you see it. Oops. So log 3 is approximately 0.477. Okay, so do the same thing on the other 3. Remember, think about what can you do, what operation can you do with the 5 and the 15 to get 75? What can you do with a 5 and or a 15 to get 125? And what can you do with 5 and 15 to get 1/3? I will also give you a hint here. You don't necessarily have to use both the 5 and the 15. You might be able to do it using just one of those numbers. So think about that too. And remember, there's a couple other examples like this on your notes. So go back and look at those if that helps. Okay. All right. Then we talked about condensing logarithmic expressions. So now we're going the other direction. We're going to start with multiple logarithms, and we want to condense it all down into one logarithm. Okay. So our first one here, all the same base. They're all log 7. So that means I can use my properties. And I'm going to look first for any numbers in front because I know that that will make an exponent. So here I've got a 2 out in front. So I'm going to deal with that part first. So this would be still log base 7 of 20 plus, I'm going to put that 2 as an exponent. So that would become log base 7 of 1/2 squared plus log base 7 of x. And then I can go ahead and do that 1/2 squared, right? So log base 7 of 20, log base 7, 1/2 squared is 1/2 times 1/2, or 1/4, plus log base 7 of x. Okay, so then I've taken care of my exponent, right? Then all I have is addition and addition. So if I've got addition, that means I can condense them all into one logarithm and multiply all of my arguments. So this is going to become log base 7 of 20 times 1/4 times x. Right? I'm going to multiply all the arguments as I was adding all the logarithms. Okay, so then if we multiply those 3 things, 20 times 1/4, that's like 20 divided by 4, so that's 5. And then my x can just stay in x. So I get log base 7 of 5x. Okay, so we took our 3 logs, condensed it down to 1. All right, we'll do one more of these. This one's kind of a longer one with lots of steps. Okay, so again, I'm going to go with first doing any exponents out in front. So I see a 2 here. Let's start with that. So that'll become, we've also got some parentheses on this one. Let's see how that works out. So I'm going to make this log base 5 of 6 squared minus, and then I've got a 1/2 here, right? So that would be log base 5 of 4 to the 1/2 power. And remember, 4 to the 1/2 power, that's the same as the square root of 4, right? So we're going to keep that in mind when we go to our next step here. Okay, so now we could do a couple different things. You could go ahead and deal with the subtraction, or we could distribute the subtraction outside the parentheses. I think either way goes pretty easily, so that's totally up to you. I'm going to go ahead and do what's in the parentheses. I think that's a little bit simpler first, and then I'll deal with the other one. Oh, and I should have done my exponent in front of the first one. I forgot the 1/4, didn't I? So let's fix that guy here. So log base 5, this would be 81 to the 1/4. And again, 81 to the 1/4 power, that means the 4th root of 81, right? Okay, so let's go ahead and do those calculations first here. So log base 5, if I went 81 to the 4th power, that's the 4th root of 81. So what number times itself 4 times will make 81? Well, that would be 3, right? Or again, you could use your calculator. Remember, you've got a button on there that will do the 4th root. Look for the little radical symbol with an x on the outside of it. Okay, then minus, this would be log base 5, 6 squared is 36. And then I've got log base 5, and 4 to the 1/2 we said is like the square root of 4, which is 2. Right? Okay, so then I'm going to deal with the subtraction part that's inside the parentheses first. I'm still just kind of following my order of operations here. Okay, so if I've got subtraction, remember we can make that division of the arguments, right? So I'm going to do, we won't need our parentheses anymore. So this will become 1 logarithm, log base 5 of 36 divided by 2, right? And then if we want to go ahead and do that quick math, that would be log base 5. 36 divided by 2 is 18, right? And now I've got another subtraction of logarithms here. So I'm again going to condense that down to 1 and divide my 2 arguments. So that would be log base 5 of 3 divided by 18. And then I can simplify that fraction. So I would get log base 5 of 1/6. There we go. Okay. All right. So again, I think it's easier to kind of, rather than distributing, unless you've got a number in front, I would go ahead and deal with what's inside the parentheses and do that kind of one step at a time. A big hint on a lot of these condensing is take it one step at a time, like write out more steps than you think you need to write out. That will always help. Okay. Let's see. I think I need to give you any big, super big hints on these. You should be able to figure those out. So let me know if you get stuck. Okay. And then kind of the last 2 parts we did here, we talked about solving logarithmic equations, and that's using condensing. So remember, if you can get each side of an equation to have a logarithm with the same base, then we can just drop the logs, right? Okay, so here on the right side, I've got just 1 log, but on the left side, I've got 2. So I want to condense that left side down to 1, which I can do because I have the same base. All right, so I'm going to start with a 2 out in front. That's going to become an exponent on my x. So this would become log base 11 of x squared plus log base 11 of 7. And our right side stays the same. So all I did there was just take the 2 in front and make it an exponent. Then I can condense these 2 into 1 logarithm on the left side because it's addition. So I'm going to multiply the arguments. So I'll get log base 11 of 7x squared equals log base 11 of 63, right? I multiplied the x squared times 7 to condense that log. And now, since I've got log base 11 of something equals log base 11 of something, they have the same logarithm on both sides, I can just drop the logs, and we're left with just 7x squared equals 63. And now I can take and solve that, just like I normally would. I divide both sides by 7, I get x squared equals 9. Take the square root of each side, and I will get x equals, the square root of 9 is not just 3, but plus or minus 3. So we actually get 2 answers there. We've got x equals 3 and x equals negative 3. But remember, we don't want to end up with a negative argument for our logarithm. So if I go back over here to where my x is, and I plug in those possibilities, it'd be 3 would be totally fine. But if I plug in negative 3, I end up with a negative argument for my logarithm. That won't work, right? So it's only the x equals 3 answer, not the negative 3. Okay, so 1 logarithm on each side, condense each side if you need to. And then as long as you have the same log, same base, you can drop them, solve it like you normally would, and then just make sure you check for any negative arguments in your logarithms. I will say on number 13 here, be careful with x plus 2 in the parentheses. Don't break it up or anything. Just keep that as x plus 2. Okay, that's the only one I think might be a little bit tricky, but just follow your rules and you'll be fine. Okay, and then the last type of problem that we did was solving a logarithmic equation where we just have 1 logarithm on one side. And to do these, we're going to just change it to exponential form, right? Okay, so to change the exponential form, remember we do the base becomes the base. So our base of our logarithm is 3. So the base of our exponential will be 3. And then the other 2 things are going to switcheroo, right? Or if you want to think of it as the answer to a logarithm is always an exponent. So this 10 is going to be our exponent, so 3 to the 10th, and that will equal our argument, which is 3x minus 5. Okay, Let's do that 3 to the 10th. That's going to be kind of a big number there. So that is 59,049 equals 3x minus 5, right? We're going to add 5 on each side. So that will give us 59,054 equals 3x. And then we're going to divide by 3, which is not a very pretty number there, but that's okay. That does not divide by 3. So I could say that our x just equals 59,054 over 3. Or if you wanted to round it, x is approximately 19,684.67, right? But leaving it in a fraction, is totally fine if it doesn't divide, right? Okay, so same thing on the next few, put it in exponential form and then solve for your x. I would want to check here if I plug that back in to make sure that I don't get a negative, but that times 3 is just going to give me that big number, minus 5, which will still be positive. So we're good there, right? So do a quick check just to make sure that you won't end up with a negative argument in your logarithm. All right, those are the basics of our solving logarithmic equations and using your logarithmic properties. Work on these. Let me know if you have questions. We will do some review next week, and then your test will be over all of this stuff, plus all of the inverse function and the basic log stuff that we did on homework and notes number 1. All right, have a good one, guys. I will hopefully hear from you soon.